Welcome to the Journey Chez Cam. Well, today you get to try a reaction in the basic solution. Please do the best you can, and I'll see you in a moment. Please do the best you can, and I'll see you in a moment. In number one, we are balancing this redox reaction in basic solution. In basic solution, I can only add water, hydrogen ions, hydroxide ions, and electrons. The very first thing that I must do is determine the charges of all of the elements. Well, oxygen here is in the negative position, and therefore oxygen is -2 times 4 is -8. This is a compound, and therefore its overall charge is 0. There are 2 nitrogens, and therefore each nitrogen is +4, and oxygen was -2. Chlorine here is -1. Oxygen here is also in the negative position. It is -2. There are 2 of them, giving me a -4. The overall charge of the polyatomic ion is -1, and therefore, in this case, nitrogen is +3. Again, oxygen is here in the negative position. It is -2. There are 3 of them. That gives me a -6. The whole polyatomic ion is -1, and therefore, in this case, chlorine is +5. And oxygen, in both cases, is -2. It is not changing. Now, what happened to nitrogen is for a single atom, it went from +4 to +3, and therefore it gained 1 electron, and it was reduced. Chlorine went from -1 to +5, and therefore it was oxidized, and it lost 6 electrons. Try to be a little consistent there. Now I separated into the half reactions. We always balance these with a half reaction method. Well, N2O4 goes to NO2. Well, here I notice that I have 2 nitrogen atoms, therefore I must put a coefficient there. I gain not just 1 electron, but because there are 2 atoms, I gain 2 electrons, and gainers go on the left. The number of oxygens is the same on both sides, so I do not need to worry about adding water. Then the second half of the reaction, I oxidized, I lost 6 electrons, so I'm going to add those 6 electrons back. There's only 1 chlorine atom. I need 3 oxygens, and therefore I will add 3 waters. When I add 3 waters, I will need 6 hydrogen ions, and I will need 6 hydroxides as well. So I will add 6 hydroxides to both sides of the reaction. Now, before I can go on, I have to have the same number of electrons gained as there are lost. And therefore, I will multiply the top one by 3 to get 6 electrons that were gained, 3 N2O4s, and 6 nitrite ions. Now I can add them back together. Well, the only thing that cancels here are the electrons. And therefore, oh, wait, we have to take care of these waters. We have 6 waters here, and we can cancel these 3 waters, leaving me with 3 waters. Therefore, I'm going to have 6 hydroxides and 3 N2O4 and chloride ions and chlorate ions and 6 nitrites and 3 waters. That is the lowest ratio of those, and therefore that is my final answer for number 1. In number 2, we are determining the element oxidized, the element reduced, the oxidizing agent, and the reducing agent. I'm putting it in this form because that's how you have it on your worksheets, and we need to get used to doing it in that form. Well, all I need to have are my brackets, and I can tell everything I need from that. And on the assessment, that's also how it's going to work. I will ask you a variety of questions. You do not need to balance the equation in order to get the answers to the questions. Well, the oxidizing agent contains the element reduced. The element that is reduced is nitrogen. The whole compound is the oxidizing agent. Chlorine is oxidized, and you could put Cl2 if you like, that's fine. And the reducing agent is the chloride ion. Now, in the oxidized half reaction, the total number of electrons that are lost would be 6. In the reduction half, I have 2 atoms, therefore I gain not just 1, but 2 electrons. And the total number that were transferred would be 6 in the complete reaction. And that's how you do number 2. Now you have another 8 to do, or 6 I should say. 6 is enough. 6 more, you're going to complete worksheet C for this evening. Your facilitator will go over last night's answers with you. And then we'll be ready to practice for the assessment. So thanks for being here, and I can't wait to see you tomorrow. Bye.